Cool. So I started working on Modal about 2.5, 3 years ago, and initially the goal was very much to build a general purpose platform for all kinds of data work, like working with data in many ways. AI, machine learning, but also all kinds of other like compute needs. We've since then gone a little bit sucked into more like Gen AI stuff, but we very much like still is a general purpose compute platform. A little bit like GCP in a way, or AWS or something like that, but with a more programmatic interface. So you work with Modal using you just write code. So basically the idea with Modal is like we have a Python SDK, might add other languages in the future, and you write code, and then we take that code and we basically deploy it to the cloud. And we do that very quickly. So you can deploy code in like a couple of seconds. There's zero configuration, there's no YAML, there's no config. The idea is like you interact with the cloud, it's like sort of programmatic in a certain way. And so let me see if I can actually live demo some stuff. Do you see this terminal? That's very hard to see. So here's I'll just show you the code first. Here's like a slightly more complex example. So in Modal, you can define containers, you can define like the code itself, like the functions, and then we take those functions, we put in those containers and execute them in the cloud. And we can also scale it out. You can specify whether you need GPUs or anything like that. So here's a pretty simple example where we're using old school machine learning library called scikit-learn. I kind of showed this because it kind of demonstrates the point pretty well, where we fit a model inside this function. So let's try to run this thing. In fact, we're not just going to fit this model. We're actually going to fit 100 models in parallel. And so the idea is like with Modal, like you can also like fan out and do these like embarrassing parallel things. I don't know if you saw this, but like it executed and spun out like 100 containers in parallel. Too bad it's a little hard to see. But the idea is also, let's say I want to like edit this code, and this is going to be interesting. It's like I can barely see. Okay, how about we just skip this?
You're using terminal Emacs?
Yeah, because I'm very old and this is all I do. The point of Modal is like you can literally like edit this code and like launch it in the cloud in like 2 seconds. Like it makes it very fast to deploy new code and like iterate in code. And this sort of experience we always wanted to have is like it feels like you're running things locally. Like as opposed to like you have to build a container, push it to the cloud, wait for 40 minutes, and then you can like trigger it through a webhook. In Modal, it's all just like code you work on locally. Anyway, I came here to talk about fine-tuning. Modal can do almost anything. Like we can run any code really. Fine-tuning is a special case of anything in a way. So like it turns out you can take this. We took Logger recipes, open source fine-tuning code base, and got it working on Modal pretty nicely. Had to make some minor modifications. So there's like actually a couple of patches we haven't merged upstream yet. The nice thing about this is there's like zero dependencies. You can just pip install Modal and then clone this repo and run it. You don't have to install anything locally. It kind of just works. I don't know if you can see the screenshot, but I'm basically just like cloning the repo and running it. That's all you need to do to get started with fine-tuning. I do want to point out like Modal is not like an API for fine-tuning. Like Modal is like it's like a cloud. We're a cloud platform. Like we run arbitrary code, and in the same sense as cloud vendors, like we charge you per usage. And so the idea is like you deploy your code to Modal, and then we charge you per like actual GPU second or CPU second, right? And the nice thing is like now here's an example. You can take these models, you can deploy them as endpoints in the cloud, like basically like serverless functions running on GPUs in the cloud. You can then, for instance, you can like import these functions in other Python scripts and then call them. So I'm just firing out the REPL here in the second screenshot and then calling this. And the cool thing is all serverless, right? So which brings the comforting kind of 2 ways. Like one is like if you build a viral app and it takes off, like the Yanni was saying, like you pick a platform that scales, right? Like it just scales up and it just like serves. You don't have to worry that Modal won't scale because you can just run things in parallel. But the flip side is also we don't charge you. If it doesn't, like if you build something that doesn't go viral and no one uses it, we're not going to charge you because it's all usage based. You scale out to 0 almost immediately because it's all serverless, right? And similarly, you can also take Modal code and turn it into webhooks or like web endpoints. And in that case, we give you a public URL, and you can call that, in this case, using curl, which is useful if you want to either integrate with Modal, like Modal with the front end, just call it directly, or if you have some other code base in a different language, you want to call Modal model. What else? We have, the cool thing about Modal is we handle these cases where you would do like, sort of what I think is like embarrassingly parallel stuff. So you can fan out and do a lot of stuff in parallel. So here's an example where I fine-tuned a model based on SQL, and then I fed it 10,000 prompts, and I just had it like batch parallelize this. And I don't know if you can see it like in the screenshot. Actually, it's extremely hard to do here. But it's immediately spinning up like 60 containers, running A100s, like multiple A100s each. Because Modal runs like a big pool with like thousands of GPUs. And parallelizes over these 10,000 prompts in about 30 seconds. So you get, you can do things also like kind of batch parallelism, like high throughput stuff. Like an open source thing we built a few weeks ago, or a few months ago, I should say, that also kind of encapsulates like a little bit like the capabilities of Modal is this thing called Doppelbot. We built this thing that it does the fine tune based on your Slack history. So you can install the Slack bot, and then there's a command to like train like a clone of yourself, and then you can talk to that. I think it sort of shows nicely what Modal can do, because it's not just like the fine tuning, it's not just like the inference, it's also the entire like Slack integration. So it's the Slack API, it's the Slack webhooks, like all that management. And so this is open source. You can also like just install it with your Slack. LLM inference is another thing we're spending a lot of time on. In particular, we're using TGI to get pretty good throughput on some of these larger models. Running, getting a few hundred tokens a second on some of these. So we have some code online to do that. And starting to get like almost cost competitive with some of the large scale APIs out there. But this is all like running your code, and you can run whatever fine-tuned models or whatever like crazy code you want to. I'll be around, so let me know if you end up using Modal. Also, let me know if you don't end up using Modal. I'm like curious what you're going to build either way. But if you do end up using Modal, there's a $500 credit, so just for you to get started, you can use this QR code. I think I'll try to, if not wasn't already shared, I'll make sure there's a link shared in Slack too. I'll be here, so just hit me up if you have any TJ issues or if you have any questions about Modal or anything else. Thank you.
Any questions?
Yes.
Oh yeah.
Question, that example you gave for the inference, like doing 10, you said 1,000 or 10,000?
10,000.
About how much that costs on your platform?
That's a good. I guess you can do the math. We charge a few bucks an hour, and so it ran 30 seconds on 60 containers.
Yeah.
So like 60 divided, whatever. I'm bad at arithmetic, but yeah, cents. Yeah. Not cool. Yeah. Yep.
Is the cost flat per unit time, or like can I just scale up infinite things per hour and it will cost the same?
Is the cost flat? Yes, it's flat per like GPU hour, right, or per GPU second. So like if you run a lot of GPUs, that many GPUs, like we'll charge for each one independently. But it also scales down to zero. Like you don't have to like set up idle capacity. Yep.
Okay, so it auto scales. How is your availability for A100 and H100s like on the platform?
We don't have H100s yet. We do have a lot of A100. We do have a lot of 40 gigabyte A100s, 80 gigabyte A100s. A little bit like scarce. So, like sometimes you run into capacity limits. But I've been running a lot of stuff on 80 gigabyte A100s recently, and there's a fair bit of capacity. 40 gigabyte is like no problem. You can run like a lot of them. Yep.
What's like the cold start time on like a A10 or something like that?
Cold start time on A10 depends obviously on the model itself. If you're doing nothing, like if you're just like starting with Python, like just nothing, it's like maybe a second. If you're loading a model, like you have to like import Torch, like load a big model, like Stable Diffusion, it's maybe like 8 seconds, something like that. Like for a 5 gigabyte model.
Is that also like charged, or is it just the inference time?
We charge for the cold start time.
Okay,
so,
okay.
yeah, because that's like user code
Yeah,
anyways.
yeah. Cool. Thank you.
Yep.
What are the most compelling LLMs that are currently running on Modal?
That is a good question. Like, I don't actually know what users like are running on Modal. I will happily admit that like most of the usage of Modal today is like more like image, audio, and video. But we do have a bunch of people that are fine tuning and running. I think it's mostly Llama 2, is my impression. Cool. Any other quick questions or? Yeah.
So once we fine tune a model, like how do we, if it's like open source like Llama, can we like download the weights and run that locally?
Yeah, totally. Like it's all like we just run code in the cloud. So like we have our own file system that you can like store data to and retrieve it. And so that's the easiest way to set it up. Is like you just store the weights. And the example I had actually shows that. Like we fine tune it and then we dump the adapter weights and then you can load them in your function that you deploy. Yep.
If I want to, how deeply integrated can I get into the actual system? For instance, if I want to do like custom, let's say kernel parameters for NVIDIA and that type of thing.
You can go as deep as you want to.
So-
Like, yeah, I mean, not maybe muck around with like direct like Linux drivers
Sure,
and like
but like,
speak to
how
the
deep
data.
is that deep?
Pretty deep, but I don't know how deep you want to go.
I'm just wondering. I'm not doing this today. I'm just curious in terms of like how deeply do you get access to the actual hardware level? Sort of
Yeah, no, like we get access to the hardware at like a very deep level, right? Like we do virtualize the Linux device
sure, of
driver.
course.
So like if you want to like go deeper than that, like that will be a problem.
Right,
Like you
right.
can't speak like PCI directly to it.
Sure.
But like you can, in theory you can like speak, the underlying driver protocol.
Okay,
to it,
awesome,
like
awesome.
I call commands and stuff.
Excellent. Awesome. Thank you.
Yep. Cool. All right, I'll wrap up with all your questions. I'll be around. Yeah.